Cool. Hello, Java people. I'm not a Java person, but I do a lot of Ruby, which is kind of like Java, but for happy people, I think, I've heard. Does anyone here do anything other than Java? You? 2, 3, 4? What do you do other than Java?
Python, with a bit of Scala.
Python, that's basically Ruby. And Scala, that's, well, not quite this, but it wants to be. So I think we have probably enough common ground to talk a bit about functional programming. Actually, even Java people do, I think, functional programming, because you have Java 8 with a bunch of, I don't know, but I've heard, word on the street is you have functional programming now. So there's no need for Scala anymore, apparently.
That does the trick.
It does?
Yes.
Makes you happier again?
No, Scala is like Tango.
I used to work with Scala and I wouldn't recommend it. I'll leave it there. By the way, if you have any questions, you can stop me like halfway through and we can just discuss, because we're only a small group, so we can talk like a conversation. So functional programming, especially in the Haskell world, people think that Haskell is super academic and that everything about functional programming is about like lambda calculus and category theory. And that turns people away from this language in particular and also the whole paradigm, which really is a shame, because I think this is much easier than any object-oriented programming I've done before. So does anyone here do maths stuff? Does anyone know the category theory? Lambda calculus? Kind of. There's jazz hands. Maths. Oh, I don't. So I won't be explaining monads. Apparently they're a bit like Mexican food, but I can't cook either. But why I do this is because I'm not that good at programming, I think. Now, in my day job, I work for a company called Simpler in Sweden, in Gothenburg. If you've heard of Gothenburg, usually it's not on the map, but it's sometimes on the map because of functional programming. Because there's a school in Gothenburg called Chalmers University, and some of the professors that teach the computer science courses there were like some of the people who wrote Haskell from the beginning. So you have like real uber nerds that work there. And some of my colleagues studied directly under these people. So they like really know their stuff when it comes to Haskell. And there are also a bunch of closure people there. So I think the company I work for sponsors the Euro closure meetup, I think. I haven't been for very long, so I don't know. But I thought I'd be the most enthusiastic about functional programming, but I'm not. I'm actually the dumbest person in my company, which is good. My background is not as a computer science person. That beer's going to fall. Okay, it's closed. It's fine. You saved it. You can tell I'm Polish. I'm like, no, the beer, save it. So my background is not in maths or computer science. It's actually in music. But computer science sort of pays the bills, right? We're all paid nicely. And I did a whole bunch of, well, I started at the bottom of the barrel, like a lot of people, in like advertising agencies, putting WordPress advertising campaigns together, which is incredibly painful. And I did a whole bunch of JavaScript stuff throughout my career, which is also incredibly painful. Because, one half of the array library is mutable, the other half is immutable, and you don't know which half is which. I asked Brendan Eich which half is which, and he just said, oh, it's like Perl. That's why I chose it to be that way. Sure, okay. So I always felt pain with programming in like PHP and JavaScript. PHP especially, really terrible. Wouldn't recommend it. And because I don't really like maintaining software that much. I like building things that people use, but I don't like maintaining stuff because it's kind of a chore. I decided to look for ways to not have broken software all the time. So I joined this other company that started doing Scala, and they introduced me to the whole software craftsmanship meetup. In fact, they ran this software craftsmanship and testing group in Germany, which is really, really big there. Still is. So I was into software craftsmanship, learned all about TDD, learned all about isolated tests and how integrated tests are a scam and this, that, and the other. And I was really sort of rigorous and disciplined about writing tests around my software to sort of drive the design of my system and to protect me from regressions. But you have to write lots and lots of tests to cover everything. And you also have to know what you want to test for before you test it. Like, writing isolated tests to drive your design is one thing. But then to protect yourself from regressions, like catching corner cases of functions, like, you want to test that it doesn't blow up in your face if you give it 0 elements, some function, or like 1 element or many elements. And you have to find all these corner cases, but you have to think about them first, right? That I found difficult because I don't know what's going to make my program blow up. And it's also really tedious. Like, writing tests that sort of express the relationships between objects in my system it takes a long time. Maybe it takes longer to not do that and have your system fail, and then you try and debug stuff. But I still think most of the isolated tests that I want to write are kind of dumb. It's like values in, values out, making sure I don't have null pointer exceptions in whatever flavor. In Ruby, that's like nil, or if JavaScript, that's undefined, is not a function. And I realized that in languages like Haskell, you don't have to write these tests because the compiler writes them all for you. Or rather, the type system doesn't allow you to make those kind of mistakes that you'd be protecting yourself against with isolated tests. So that's my sort of motivation for using Haskell. I do use Haskell in my own work all the time. And I do use it at my day job too. Sadly, we have old Ruby stuff, which is always broken and is really hard to use. And we have newer Haskell stuff, which is really easy to use. And the general consensus is that people don't use Haskell because it's too hard. They use Ruby because it's easy and it makes you happy. And now, in my head, that's completely the wrong way around. Ruby's hard because sometimes some function will return nil, and you don't always know why or where that nil is coming from. And that's enough to completely destroy your system at runtime. But maybe this sort of null pointer exception, or this nil that isn't captured, maybe that's not always being run all the time. Maybe that happens like on the 29th of February. So once every 4 years, your system goes down. You have no idea why. Everything's broken. So yeah, type system protects you against that kind of stuff. So what is Haskell good for? That's something I've been asked before, so I thought I'd come up with a good answer. I think it's good for everything. Of course, I'm advocating for it. In my case, I build internet stuff. So I'm really into building software as a service type applications, stuff that you would normally use Rails for, or I don't know what you do with Java. I think enterprise stuff. I work on smaller teams normally. And I've worked with a lot of banking things where you have to be really rigorous about money. And I'm really paranoid about people's money. Like if you, I worked at a company in Poland, I won't say who, but they expressed all monetary values and all accounting stuff as floats in this. Yeah, that pain you're feeling, it's appropriate. They lost a lot of money, like a lot. And they were, I think, one of the most funded Polish companies, because it's like a Silicon Valley type company as well. If you dig for 5 minutes, you'll find who it is. But they lost a lot of money, and they had to fire a lot of people. You probably know some of them. You know one of them.
Yeah, I know all of them.
You know all of them.
Well, I didn't know that story.
Yeah, I did warn them. I said, shit's fucked, and you better fix it. I'm like, no, it's fine. PHP's great. So
They've rewritten it, JavaScript, I think.
Oh god.
Now they don't lose money, they will have amount function defined.
Yeah. Account's not defined either. That's okay. I'm not there anymore, it's fine. So I think if you work with people's money, or you work with anything that you care about, if you care about like the fundamental correctness of your system, which I think you do in most cases, then it's worth going with a language that gives you a whole bunch of guarantees about safety. Now, I got to say, there's this kind of inside joke or rumor, or when people talk about Haskell, they say that it's so safe that if it compiles, then it works, and you never get runtime errors. And that's not true. Like, I'm advocating for Haskell, but I got to say it's not all unicorns and rainbows, right? You can still get bugs, and you do. For example, you can very meticulously and very sort of accurately describe incorrect logic in your system. I mean, the compiler can't protect you against that kind of thing, right? If I wrote a system that said, okay, my company is going to give 1,000 zloty to every man in Poland every month whose last name ends with ski, I'm going to lose a lot of money, because that's almost everyone. And the compilers say, yeah, it makes sense, so I'll do it. So it can't protect you against that kind of thing. And it also can't protect you against stuff outside of your system boundaries. And a lot of internet software, at least, I don't know if you all work with internet stuff, but I do, that's where a lot of the money is, I guess. You can't really protect yourself against stuff coming over the network. You can describe what you expect to receive and try and fail if you don't receive the right data over the network that you're expecting. But that's a potential point of failure. And there's one other potential point of failure that I think happens the most, and it's a sad part of Haskell. We have this library called Prelude, which is sort of the basic library that has all your sort of standard functions that you use all the time in it. But for some reason, not all of the functions are total. They're what we call partial. The one that comes to mind, it's the most obvious in my head, is a function called head, and it gives you the first element of a list. But if you look at the type signature, it says this function takes a list of something, a list of A, and A can be anything, and it will return you an A. So whatever that thing was, it'll return the first one. But if you have an empty list, then it just fails. You get a runtime error, which is it sort of ruins the point of a safe programming language, runtime errors, because you don't want runtime errors, right? So you kind of just have to know, and this comes with a bit of experience, a bit of reading, you just have to know not to use those partial functions. There are functions that behave more correctly. So if you go on this thing called Google, which is like Haskell Google, right? You can look it up. You can search for functions by their type signature, which is really smart. I don't think you have this in any other language ecosystem, as far as I'm aware. So we would think, okay, we want to find the first element of a list. Head, which is the dangerous one, we know that it takes a list of A and gives us back an A. But what we actually really need is something from a list of A to maybe an A. So we get some value there's always going to be a value there, and it'll say this is just the value, or there's nothing there. So we can handle that case, right? When there's no value. So you can type that type signature into Google, and it'll suggest a function that you can use. I think it's maybe data maybe from list. I don't know. I don't remember. I look it up in Google. And on the topic of safety, again, I think it's common for a lot of companies to write their software as a service or their product very, very quickly as a prototype. And then they think, okay, that was just the prototype. We're not actually going to use it in production. And then we're going to rewrite it properly, right? They'll have the big rewrite, the version 2 of their product, and that always fails, almost always. It's sort of like a sad joke. Rather than you laugh because otherwise you'd cry about it. Always your prototype ends up in production. And that's not exclusive to software either. I think the Trans-Siberian Railroad was the same story, the one from Moscow to Beijing. Parts of it were built with people's like bare hands with the wrong sized track. And it's like, oh, well, this will do for now. But then they actually ran trains on it and people actually died. In our case, most of the time, people don't die if someone screws up in a software as a service. But I gave this talk in Belgrade, I think it was, and I said, luckily, in our work, nobody dies. Then someone came up to me afterwards, like, actually, you know, if I fuck up, then people die. Okay. I don't work on anything that dangerous, so I'm lucky. I don't know everything about Haskell, and I can't teach you everything about Haskell. But if you want to learn Haskell, the language, from scratch, then there's a really good book out now called Haskell Programming from First Principles, I think it's called, by a guy named Chris Allen and a lady named Julie Moronuki. And it's a really cool book because the lady, Julie, she has no programming experience at all. She's a language person, a linguist. So you get the perspective of someone with lots of programming background and also one with none. So even if you're coming at functional programming like completely green, you have no functional programming ideas, you can still learn it as a normal person, which is really handy. So I'd recommend you buy that.
Repeat the name of the book.
Yeah, it's Haskell Programming from First Principles. I don't take commission on their sales, but I really should now. Okay, I think I've talked enough about safety, about the language. Does anyone here do any front-end work? Any JavaScript? Anyone? Anyone? Bueller? No. Okay. If you have friends that do JavaScript and you care enough to advise against it, which you should, then I can recommend using a language that compiles to JavaScript. The one I prefer is called Elm, which is very much like Haskell Lite. It's really easy to understand, and it's super, super safe as well. So it makes it actually nice to build user interfaces for websites. There are some companies, I think No Red Ink is one of them, and they're the main company backing the Elm project. They've written 80,000 lines of Elm, I think, and the number of runtime errors they get is 0, which is good. It's the right number of runtime errors. It's sort of unheard of in the front-end sort of JavaScript world. Usually everything's broken in JavaScript, but with Elm, it's been my experience as well, that you just don't get errors anymore. Apart from, again, across network boundaries when you're decoding JSON. Yeah?
You said that Haskell is a safe language, yes?
For the most part, yeah.
It's safer than other functional languages that provide more imperative constructions than Haskell.
I'm sort of glad you said imperative, because that's something I wanted to bring up in this talk. Is it safer or less safe relatively to other functional programming languages? It's safer than, say, Clojure. It's more rigorous. It has a much stronger sort of type system, much stricter type system, rather. I couldn't give you the rundown of all of them, but it's generally known as one of the safest and strictest. There are others, apparently, but I haven't worked with them, like I think Agda or Idris, that have super strict type systems, and they have a thing called dependent types, so that the parameters going into your functions, not only do you know their type, but you have some sort of validity on the value of that type as well. So you can say, this function that takes an A and a B, this A will always be an integer, and it'll also always be above a value of 100, for example. So that's a little bit more safety, but I haven't worked with that, so I can't really advocate for it. Does anyone here run a company, or is anyone a hiring manager? Does anyone know a hiring? Oh, you do. I think. Okay, I remember seeing this talk once. People are talking about some new programming language, this new sort of ecosystem, and it's a bunch of PHP developers in the room. And all the PHP developers ask this question like, oh, yeah, your new thing sounds nice, but there are thousands of PHP developers in the world, so it's easy to hire, but how many people do your thing? And the answer to that question was, yeah, maybe there are thousands of PHP developers in the world, but how many do you need for your team? 2 or 3? And the person who said that was David Heinemeier Hansen, the author of the Ruby on Rails framework. And of course, that's now huge. So this problem of, well, I'm not sure if my team can use Haskell in production because there aren't that many Haskell developers, relatively speaking, is really a moot point. Doesn't really matter. And if you look at the numbers, it's becoming wildly more popular now anyway. It's having a sort of resurgence. I'm guessing it's because people are feeling the same pain that I feel with everything being broken all the time. In the Haskell ecosystem, you have a few different frameworks. The one that I use is called Yesod, which is Hebrew for foundation. Bit of trivia, if you like that kind of thing. It's the most similar to Ruby on Rails. So it gives you a whole bunch of things out of the box. It's really user-friendly. You don't need to know everything about Haskell to use Yesod even effectively. And I'll show some examples of that later. There are others if you don't want so many batteries included. My colleague at work uses a framework called Scotty, which is analogous to Ruby's Sinatra. I don't know what that is in Java land.
There's Scala for Scala.
There's a what?
There's a Scala for Scala. And there's a Spark Java. Oh yeah, not the most popular Spark. Yeah, it's niche. The less popular.
I mean, I hear Java, I just think Bill Lumbergh. So, you know, the office space, corporate world. I don't know. I think now's the time to skip to a slide. Sorry about that. So yeah, I said that the framework I use is called Yesod. That's how you spell it. That's not their logo. maybe not so obvious. No, that's Michael Snoiman. He's the author of Yesod, or the main author. I was talking to him about me doing this talk, and I said that I couldn't find a sort of high-resolution logo of the framework, because if you look at any JavaScript project, or even these days, if you find a security vulnerability, it'll have its own marketing page. I remember Heartbleed. It's got a logo. It's really sexy. It's a bug. We don't need to market bugs. Jesus Christ. But the JavaScript community does marketing really well, I think. I think it does it in a very juvenile way with lots of unicorn emojis, but if that gets you excited, fine. And clearly their community's thriving. And Ruby's kind of the same. If you look at any Ruby project that's popular, it'll have some cutesy name, like VCR does playback. Get it? Yeah. But Haskell, there aren't so many jokes, and it's not so cutesy, and they're not so good at marketing. I don't know why that is. Is that the main reason why people don't use Haskell so much? Probably not the main reason, but I'm sure it accounts for it a little bit. So if it's not clear, Yesod, framework, Michael Snoiman, author. He's a very nice man. Okay. Oh, now's a really tedious slide. I'm sorry about that, but we're tedious people being programmers. This is a bunch of numbers. I always ignore the side on the left, and I always look at the side on the right. This is talking about performance, the performance specifically of sort of web servers on the internet in implemented different languages. So people ask, is Haskell fast? Short answer, yes it is. If you look right at the bottom of the chart, I don't know what the server does exactly. I think it's just serving static files through the server. But at the bottom, sort of 104th place, you have Django, which does 2,500 requests per second, and Rails is about the same. PHP is a little bit faster. It's not on the chart, but I think it's around 3,000, 3,500. I decided to put this slide in because that Polish company I was telling you about, who I used to work for, they did everything in PHP. I suggested we do some more stuff in Ruby because it's a bit easier than PHP. And a bunch of people there said, oh no, Ruby's too slow. And it's really. How slow is too slow? Performance didn't really matter for that domain, but some people I was working with are saying, PHP is good because it's fast, but we should use JavaScript because it's faster, which is ridiculous.
Technically it is.
Technically it is. It sort of doesn't matter, but technically it is. And you see Node.js is faster, sort of like 11,000 requests per second, but then towards the top of the chart, you have, in third place, the web app interface, which is a Haskell thing, and that's 81,000 requests per second. Haskell is generally faster. It's sort of like C level usually, but you need to take those numbers with a great dollop of salt, and actually any performance figures you have to sort of be skeptical of, because it's really easy to tune a particular machine and a particular scenario to sort of support the propaganda you wish to market to people, because you could do the same thing and make Node look really, really fast and Haskell terrible if you want. But generally, Haskell fast. I'm going to switch gears now and talk about something else. And this is maybe applicable to you if you're doing Java, I think. Are there any sort of DevOpsy people here? Anyone do anything in operations? Has anyone launched a server before? Yes. Good. So for a good long while, I was using this thing called NixOS, which is it's billed as a pure immutable Linux distribution. It's pure and immutable in the sense that any sort of system packages you install, when you upgrade them, it doesn't overwrite them. It'll install the next version adjacent, and then we'll just update a bunch of symbolic links to point to new versions of things, which is really handy because if you upgrade stuff on your system and you find it doesn't work, it takes 0 seconds to switch things back to old versions. It's also declarative, which is kind of a buzzword that people in the functional programming community use. But it's declarative in the sense that when you're setting up your system, you don't have a bunch of imperative scripts. Like you don't have a bunch of bash scripts. You don't sort of go in with SSH and then change this file and change that file and keep state in different places. You define everything locally in one configuration file, and then everything is built to that description, which is really, really handy. It's like a single state store, like you would have in the like the React Redux world, if you're familiar with that. I don't know if there's a Java equivalent of single state store functional reactive programming. I don't know. But NixOS is sort of an ecosystem of 3 things. There's NixOS, which is the operating system. There's Nix, which is the package manager, and apparently there are a whole bunch of smart ideas behind that, but I can't really tell you about them. And there's also NixOps, which is a cloud deployment system, I guess. It can provision servers for you and it can deploy your software for you. Has anyone heard of Bluegreen Deploys? Yeah? So, at a high level, the idea of a Bluegreen Deploy is that you have your software, and it could be Java stuff, I think. It can be anything. So this is not specific to Haskell, which is why maybe it's interesting to you. The idea of a Bluegreen Deploy is that you have your software running on your server, and then when you want to push some new code, you send up the new version of the software adjacent to your old one, and then once the running process has finished its running requests, it just switches some symlinks to the new one. So you have like 2 versions of the same thing running, or 2 versions of working software running. Again, if NixOps does that, and if there's a problem with deploying, it's really easy to roll things back because it just updates some symbolic links again. You don't need to tear down the server and deploy everything from scratch. That's handy. But there are some drawbacks as well. With NixOps in particular, you need to have the state of your deployment in one place. And I don't know how that works in teams. I've read about teams who use NixOps that have like a shared deployment machine, and they'll send a message to the deployment machine, and then the one single deployment machine will then do the deployments. That seems like a potential single point of failure. I don't know. I don't use this anymore, not because it's bad, but because for my own projects it's maybe a little bit of overkill. What I use to deploy my Haskell software is a thing called Keter, which is made by Michael. So thank you, Michael. And it does largely the same thing. It does these Bluegreen Deploy things. You compile it locally, and then you put Keter on your server. And Keter will listen for, whenever you send it a tarball of your application that's compiled, it will finish listening to requests on your old program and switch them to the new program. And it'll also do process monitoring. So if everything explodes, then it can restart your software as well. And it does logging, and it does a whole bunch of stuff. And it's also a reverse router, so you don't really need Nginx. You don't have to fiddle with that. It just does everything for you. It's sort of the Apple back in 2008 of the Haskell world. It just works, right? And I don't really want to have to fiddle with this kind of stuff because I'm not an expert DevOps person. I'm just some guy. I don't want to have to fiddle with this kind of stuff. Okay, let's talk about Jezen again. So this is some Haskell code. I know you do have this in Scala, but in Java, do you have like any guarantees around routing to a web application? Who does internet stuff here? A few, most, yeah. So in any kind of web framework, you have routes because requests come into the thing, and then you route those requests to functions in some controller or some handler, or I don't know. Do you have any guarantees in your software about these functions exist when they're called? No? Yes?
Sometimes the Spring has annotations, so if to annotate something, the method has to exist.
Okay, but it's
routing through the code.
But you can annotate two things with the same thing. Right?
Yeah, that's true. Yeah.
And it will just tell you in runtime that you have like two methods with the same roots.
okay. So that's a bit like in the Ruby world in Rails. You can have a route that goes nowhere, and then you won't know about it until someone hits that route, and then it says, "Sorry."
No, it's not other way around. You can have like route that is defined in two places.
You can have
Right.
Like your dashboard has two controllers.
Yeah.
And you will know it when you start your application. It's like, oh,
but it's not when somebody actually hits the root.
So it's like a little bit better, but we are not there yet.
Not there yet. Yeah. I mean, the word sometimes was, I think, the operative word before. That doesn't fill me with confidence. In Jezen, and I think in most Haskell frameworks, you have that level of confidence that every route will go somewhere. If you define a route and there's no matching handler, then it just won't compile. Then you know that it's safe. Does it work the other way around? I think it does. It also has this concept of a reverse router, which is actually common in lots of frameworks. So does everyone here understand reverse routing? That rather than hard coding paths in your application, you use the named route, and it'll give you the actual path. It has that, of course, but it also has sort of type safety in the sort of the segments of the route. So this is pretty easy to read. This is an embedded domain-specific language, and it compiles to proper Haskell. So this last route, it matches /thing/some UUID. So if a user comes to my website and goes to /thing/4, 4 is a number, but it's not a UUID, and the runtime will see that and say, okay, but that's not a valid UUID, so it can't possibly match any handler, so I'm not going to try and do anything. You'll just get a 404, which is kind of nice. It's a sort of nice philosophical way of looking at it. And also at compile time, if you say this is a UUID, then the handler that receives this route you've got to say in the type signature that this takes a UUID as well. You can't say this takes a number, because then they won't match, which is really, really cool. Also here in your routes file, you have the path to the thing, and then some named route, and then the HTTP verbs that it responds to, which is pretty straightforward. But these verbs are also checked in that /thing/ the UUID is named proxy R for resource or route, but resource in this case. And defining those verbs means that you have to define the handlers get proxy resource, post proxy resource, and options proxy resource. So it'll say that if you don't define those handlers, then it also won't compile. So you get lots and lots of safety that way. Yesod also has a embedded DSL for models. So I don't know how it works in the Java world, but in the Rails world, when you're defining your schema for your database, when you're sort of modeling your business logic, you write migrations. Do you have migrations in Java? Sorry? What are migrations? So, yeah, like database migration. So you'll say, okay, create me a user table and add a bunch of columns, and this is the type of thing. And then after that, someone will say, actually, we don't want this column in the user table, so remove this column. And then your framework will play back all the migrations in chronological order, and then what you end up with is the correct version of your schema, right? I mean, this, anecdotally at least, this becomes really problematic over time. At my day job, we have some legacy Rails applications that are like 5 years old, and a lot of the migrations from a few years ago, part of the migrations reference classes that no longer exist in the system. So you can't play back the migrations anyway because they're totally invalid. So I'm not really sure about that whole migration idea. In Yesod, what you do is you sort of just declare how your database is meant to look. So we say we have a user model, and a user has a name, which is some text value. It has an email, some text value. You could say email value at this point and put some validation on that. I don't bother. And then we have some created at value, which is a UTC time, and we have a unique index on email, because everyone should have a unique email address, right? And email proxy would be a separate model, separate table, largely the same thing. And the cool thing about Yesod in this case is that you don't have to write the migrations. It will look at your database schema and figure out the difference of what you have and what you don't have in the database, or what's surplus, and it will write the correct sort of SQL migrations and apply them to the database so that they're in sync again. Yeah.
How the changes in the data?
Sorry?
How the changes in the data?
How do you change data? Then you have to write some raw SQL. It will only ever do things that are not destructive as well. So if I run this and it creates these two tables with all those fields, if I then remove one of the fields, it'll say, hey, you could potentially lose data if I do this, so I'm not going to do this. You have to run this manually, which is nice. I mean, I think there's no other way to do it. You have to sort of think, how am I going to handle this potential data loss? There are also domain-specific languages for templating. Sorry, yeah?
But that's not... it's two different stuffs. Schema migration or in general, database migration. I mean, improving the database, adding columns, that's different from the ORM, which basically is responsible for communicating with the database and let's say, getting this stuff from the database. That's different stuff.
Yes.
So in Java, we have this hibernate stuff, so we can also add some annotations on the field, and it also look in the database and look for the right columns. So you talked about migrations, and then you talked about ORM. That's different stuff. So,
But this sometimes comes
Did I?
together. It sometimes comes together. In Play framework, for example, there's Slick, which has also migrations. In Django, we have also migrations, so this is bound.
okay.
I mean, there are ORMs in your code as well. I mean, this is just sort of defining your data structure, essentially. But then in your handler functions, where you have your business logic, that's when you would be defining how to get stuff from the database, how to put stuff back in the database.
So migrations, they create a database tables, for example. Does this stuff do it? No.
Yes.
Okay.
Yeah, that's sort of the point. It's like normally with Rails, I don't know how it is with Java, but normally with Rails, you would say, okay, do this, then do this, then do this, then do this, right? And there would be sort of operations on a database. So to create this table, add this thing.
Yeah.
Here you don't say do this, then do this, then do this. You just say, here is how it should look, you figure it out. And it does that. And it'll create things to do that, but it won't ever delete things. Then you're on your own. It's manual then. Yeah, so there's also a DSL for templating, for HTML. I don't have an example of it, but it's almost the same as normal HTML, except you have some niceties like you can reference functions in your handler files or anywhere in the system, and there are like type guarantees, and you know that they're always going to be there at compile time. There's also, because Haskell is indent sensitive, then the templating is also indent sensitive. You don't need closing tags. You just indent stuff to the right level, and it will automatically close tags and nest things correctly. So you never have this problem of invalid HTML, which if you're working with more junior design front-end sort of people on the team, it's surprising how common that is. So it's really nice that whenever they're editing a file, it'll just completely blow up in their face if they do something wrong. It means you have more guarantees that your stuff will always work. Same thing with the JavaScript system in here. It's basically normal JavaScript with where you can reference stuff in your handlers. You can reference stuff in your templates as well. So if you can give some header element on your website, some ID, and then you can reference that ID from your JavaScript, and then you know it's always going to be there. Because without those kind of guarantees, if you have normal HTML and JavaScript, you can have a header with some ID, and then you can have some like say jQuery function that changes the header or does something to it, but you have the wrong selector, so they don't match up. It's a very common sort of problem, which you don't get so much if you use what the framework gives you. And then it has a pre-processor for CSS as well, but there's not too much interesting going on in there. You mentioned something about Haskell versus imperative programming, right? I actually read an article by a Java guy today, just coincidentally. I saw it on somewhere, maybe Hacker News, who said that functional programming is terrible. Of course, that's the way you get clicks on your website. Because the human mind is just not designed to, it doesn't map to mathematical equations very well. And that actually we all think imperatively, so we shouldn't do functional programming. But that's complete nonsense. I mean, we do imperative programming in functional languages. If you look at some basic Haskell code, you'll see that, do this, then do that, then do that. You just don't sort of derive values in this sort of stateful way. Like, if you're doing some C family language, you'll set some value and then you'll loop through something and keep changing the value outside of that scope. That can be confusing to keep track of. You don't do that kind of thing in Haskell, but you do imperative programming. There's even a do syntax that says literally do this, then this, then this, then this, and you get this value. And this handler, this is like analogous to a controller action in Rails, or I don't know what it would be called in Java. But you have controllers, right, in your MVC framework. So this is like a controller method or action. The first line at the top just names the module. So module handler home. It's naming the module, so you can reference it in other places. Import. Okay, the first import is a Haskell keyword, and it imports a module, and the second import, capitalized, is the name of a module. Maybe it's a little bit confusing that the author of the framework named that module import, but it gives you a whole bunch of basic functions that you're most likely going to want to use in your handler. And then remember how I said in the routes file that if I have a home resource and it responds to GET requests, I'm going to have a GET home resource function. That's what I have here. I can see from the type that it's a handler that returns some HTML. That's pretty straightforward to understand. The type signature, sort of the function name with the 2 colons and then the types. The fact that there's only one thing there are no like arrows. Do you know what the arrows look like? Like that type signature. The fact that there's no arrow tells me that there's nothing to be passed into this function either. It has no parameters. So it's a common thing in Haskell that it's really easy to read code because you don't need to read the implementation of everything. In a lot of cases, you just need to read the type signature. So you understand what values you're going to get out of a particular function. Not the case in Ruby. In fact, I spent most of my day today chasing up why some method was sometimes returning nil. And it wasn't expressed in the test cases that I had either. You can understand how painful that must be. Like sometimes it might be nil, you never know, it's up to you to sort of handle that. In Haskell, you'd have to say, this maybe will return a nil, in which case you always have to handle it. If it doesn't say maybe something, then you know the value is always there. You don't get nils. Sort of reminds me of a recent Uncle Bob article. Does anyone here know Uncle Bob? Yeah. See, Uncle Bob would not agree with me. Uncle Bob recently wrote that functional programming is kind of a waste of time and that actually you should fix everything with unit tests and that it's sort of your responsibility to write unit tests for all of your null pointer exceptions, and if you don't do that, then you should stop being a programmer, quit your job, and never program again. Yeah.
I think Uncle Bob is thinking about retirement.
Yeah. I was thinking he's an arsehole, but who said that? Yeah, anyway, let's back to this code. So I did say that there was this do syntax, it's imperative, procedural, yeah, it's there. So get home resource equals do this list of things. And on that first line, MUID, that's not a very good variable name, I'll concede that. That stands for maybe a user ID. So it runs this function, maybe auth ID, which looks in the database, tries to get the right user ID from the session. If it gets one, I'm checking the value of maybe user ID in the case sort of statement. I'll say if it doesn't get one first. So if I don't get a user ID, so the user is not logged in, I'll get nothing. So I can go on that branch of the case statement. And in that case, I'll set some page title and render some template. If I get a user, then I know we're in the just something branch of this case statement. Here it says just underscore. Underscore, if you've done Scala, you know that it's a wildcard pattern. Basically, I'm expressing the idea that I don't really care who the user is because I'm not using that information. I could say just user and then use that user object named user, but I don't really care who they are because I'm just going to redirect them to some other place. In this case, the dash resource. This is also kind of interesting because this is what a form looks like. You have, you can write forms normally in HTML if you want to, but it's really nice to be able to use the framework to give you a bunch of guarantees around that your form maps to your model objects in the system. Okay, so I have this is some system I wrote, I think last year. I have this concept of an email proxy. So this system, is sort of a backend for forms. If you have a static website, I really like static websites, and you have a contact page, static websites don't have a backend system because they're static. So you don't have anywhere to send your form to. There are other services that do this. I think FormSpring is one, and then FormKeep, I don't know. But yeah, so this system, if you have a contact page, you can send that form to my system, and I will email it back to you, right? So I have this concept of an email proxy, and that's all it is. And this form takes a user ID and some text, and the text happens to be the user's email. It probably would have been clearer if I used the type system better. Like that text in the type system, I know it happens to be an email because I've named it user email, but I could have made an actual type alias for text and called it email instead. So I know it's going to be an email. And that would have been in this model, right? Email, text. If I had done email is an email, different type of thing, it would have been clearer in the function. But that's my own bad programming. And then this function will sort of render all the markup for the form that you need. You can ignore the operators on the side. You just sort of gloss over that and just know that they have to be there. We'll go through these line by line. The first one, a rec. Forget what a means, but rec is short for required. So you know this is a required field. And if you don't have that, if the user doesn't submit that value, then they get a 403, 40 something, I don't know. Then it says URL field. So I didn't define this. This is in the framework. You can just say URL field, and the framework gives you some out-of-the-box validations to make sure that the value passed in is a URL. It'll pass the value for you. Domain, I think, is the placeholder, or maybe the label, I don't remember. And then nothing, I also don't remember. And then the second line is essentially the same thing. It's the next field of my form. It's required. It's an email field, so it must be a valid email address. Otherwise, you'd have to write the validation yourself. That's a bit tedious. And that's where the form is going. And then you have a couple of other things. You have lift, which will run some function in the background, which could be different every time. Because Haskell is pure in the sense that every time you call a function, it'll give you the same output, the same input. But that can't be true if you're dealing with the current time. Because if I call a function now, the current time is 18:29 and some seconds. If I call the same function in 5 minutes from now, it'll be 18:34 and some seconds. So then it wouldn't be pure anymore. So you have to express that this function does things that are not pure. It goes over some boundary, right? It's the same thing with the second last line. You can ignore most of that, but basically I'm getting some random identifier. I'm generating a UUID to store this record on the system. And then in your SOD, you use pure for stuff that you want to store in the database, but are not expressed in the form. Like, a user's not going to come to my website and put their own user ID in the form. That wouldn't make sense. Otherwise, you could put other people's user IDs in forms, and that also wouldn't make sense. I'm probably running out of time. So I'm writing about all this stuff in a book. It's called Haskell, but quickly, because I'm very impatient and I want to learn all this stuff now. So if you're interested in that when it's done, then that's the website. You can just add your email address there and you'll get an email when it's ready to be read. And that's all I got. So thank you very much.
Try to introduce developers to Haskell. So how long does it take for them to be productive?
In my experience, not very long to get productive. I think the biggest hurdle to getting started is just it's some psychological barrier of, oh, this seems weird. I don't. That's the sort of thing I'm trying to dispel by giving these talks. I've had some really weird occasions when selling Elm, which is essentially the same thing. Elm looks a lot like Haskell. In fact, it's implemented in Haskell. But selling that to people who only know Ruby and JavaScript, they'd be like, yeah, but it looks weird. It's like, okay, there's more to programming languages than how it looks, you know?
Ruby developers know the language looks weird.
Sorry?
Ruby developers told you that this language looks weird.
Yeah, maybe it doesn't make them happy or something. I don't know. I mean, I've spoken with people who will say, oh yeah, Elm looks nice, but I prefer the syntax of Opal.js, which is like you write Ruby and it compiles to JS. So you have something unsafe that compiles to something also unsafe. I mean, maybe you like the syntax, but what guarantees are you getting from your tools? Remember, like, languages are just tools that help you get a job done. The functional, pure ones happen to make my job easier, which is why I use them. Yeah. There any questions? Yeah.
Do you know Haskell versions of JVM apart from Frege?
No. that's the one I was going to suggest, but I haven't used it. I have no idea, and that's all I know. Sorry. Any other questions?
One small one, but rather regarding the Haskell syntax. So I've touched Haskell a little bit, but I'm lost on those types about the arrows. So what do they depict exactly? So for example, like handler and something else.
Like the left bracket, $ right bracket?
No. Could you use like next few steps to the first example?
This one?
No, the previous one.
This one?
So you get handler and HTML.
Yeah.
So that's like not that you accept like handler and output HTML because there's no.
No. It's if I use this example, it's a little bit better. You can read a Haskell type like if you have three things, because there's two arrows, so it says three things. This thing takes a user ID, and the next argument is some text argument, and the whole thing will return a form email proxy, or form of email proxy. It's like form wraps the thing, right? So that previous function, there are no arrows, so it doesn't take any arguments. It's just, yeah, this is the value, the type of value that it returns. I can sort of explain why things are read this way, that it doesn't, like in other languages you would say it takes two things and returns one thing. But actually in Haskell, you don't really need to know this to be sort of productive with it, but it's handy to know. Every function in Haskell, and actually every function in the Lambda calculus, only takes one argument, right? So what this function actually does is it takes a user ID and then returns another function, and that function takes a text. And then once you apply that, then you get the last value. So everything is like partially applied, until you give all the arguments, right? I mean, this idea of partial application also works in JavaScript, so it's sort of handy to know how that works.
What does the $sign means?
Which one?
All of it.
All of them, or they apply different forms.
It means I can pay rent this month. No, okay, so the first, this $sign wrapped in the angle brackets.
No, but the second one.
The second one, even easier. That's
Like resistance, but without resistance.
basically, yeah. I can't remember exactly what it does, but in practice, you use it to not wrap things in parens.
Yeah, so the thing on the right will be wrapped in.
Yeah, it's right associative, I think, and it'll do this thing and then pass it to this thing. I mean, otherwise, I would have to put a bracket, a parent here before lift IO and one after next random. Yeah. In practice, yes. And then this dollar with the brackets is a thing called fmap. You can have. Do we all know fmap? No. Okay. It's really actually a simple idea. It's a thing called a functor. And no. Bear with me. It's so easy. No. It really. I'm not a maths person, and it is easy. I promise. So in Ruby, we have duck typing, right? In a lot of languages, you have this idea that I want to map some function over a list. Okay, what if it's not a list? Isn't that annoying that you have to like change your set to go into a list before you can map over it, right? So in Ruby, we have duck typing, so we don't say what's the type of this thing. We just say, can I map over it? So you can map over lots of different things, and the result is the same. Now, Haskell, you can't quite do that because it cares a lot about the types that are going into functions. So if you map over something, it must be a list. Okay, but that's not very practical because you want to map over other things that are not lists. So you have a thing called fmap, or like a functor is anything you can map over. Behind the scenes, it checks that it adheres to a whole bunch of rules. They call them laws. You don't really need to know that to use them. It's just mapping over stuff that's not necessarily a list. Same thing with monoid, I think. It's like just concatenating stuff, just gluing stuff together. Stuff that not necessarily responds to like append functions or whatever. You get the idea.
You said that Haskell is, in your opinion, better than Scala or Clojure. Can you give some examples? Because you talk to Java guys, so we need some examples.
I'm not going to bash Clojure at all because the next guy is talking about Clojure. And I like Clojure. I've done a little bit of work in Clojure, and generally I like it, but it doesn't give you all the same sort of correctness guarantees that Haskell does. That's really it.
You mean that the base argument was that Haskell compiler will not compile a code which basically doesn't have some functions for routing or something like that?
Yeah, I mean, the sort of core of my argument is that I don't trust myself to be super rigorous and to make sure there are no mistakes in my system. It wouldn't make sense to either. I mean, we know humans make mistakes. That's normal.
And a lot of these errors are, let's say, found by compiler, not at random.
Yeah. In fact, in some language ecosystems, for example, JavaScript, if you're doing something super trivial or you're quite new to JavaScript, you'll just write sort of cowboy-style vanilla JavaScript with no guarantees. If you're really, really advanced, then you'll add in some sort of static analysis, you'll add in some linting, you'll add in some immutable library, you'll add in a whole bunch of these things to try and protect you from yourself. So clearly people want all this safety. They just don't want it hard enough yet. But Haskell gives you all that safety that you probably do want in your system. Anything else?
Yeah, I have a question about the language itself and the ecosystem over it. So, is the language actually evolving at this time? Like, there are new versions of it?
Yeah, I think it's not here, but the do syntax is a relatively new thing. It's actually just sort of syntactic sugar to make things easier to understand for normal people. Once you figure out how that desugars, it's actually quite easy. Then you understand this bind operator, which is like the two arrows and the equal sign, which looks really weird, but it demystifies that a lot. There are always things going on in Haskell development. There are always advances being made, and it's pretty clear if you're into the sort of corporate world and the enterprisey world, it's pretty clear that some of the bigger players can see that this is like the real deal. This is what we should be investing in. If you look at the job market in London, Ruby developers are getting 60, 70, 80,000 pounds a year. Barclays are currently hiring Haskell developers. Salary is £250,000 a year. So if you want £250,000, learn this. If that doesn't sell the language. Anything else? Yeah.
What about debugging? Because it's very often a problem in functional languages.
Good point. In my case, I have had to debug stuff. Usually my systems are small enough that I know where to look. The problems I've had are with partial functions, as I mentioned earlier. Like, I'll set up a really sort of poor man's version of error reporting. I'll just like send myself an email whenever I get a runtime error. And almost always that's a partial function that I've used. Like, it tried to find the head of a list, but the list was empty. And I haven't managed to get stack traces from that. I don't know what the deal is with Haskell stack traces, so I don't know about that. Not directly related, but sort of tangentially related, is profiling performance. That's something that's really easy to do in Haskell. The tool that I use, or that I suggest you use, called Stack, which manages the compiler, manages your packages, manages everything. That works really nicely with with the compiler. It profiles your software really nicely for you, gives you nice like flame graphs and stuff. I think there's a lot less debugging that you have to do in Haskell because you get rid of most of that stuff up front, which is better. It's cheaper, right?
What IDE would you recommend?
Sorry?
What IDE would you recommend?
IDE. I'm a Vim guy, so there is an IDE, I think, called Haskell for Mac, but then you've got to use a Mac. I don't know. I couldn't tell you because I'm, terminal nerd. Anything else? This is good amount of discussion. Yeah, we good? Okay. Thank you.